Okay, everybody, this is the audio file that's supposed to go along with the video file I posted labeled 3.1 example D for 910 only. I recorded the whole thing and the audio didn't work, so maybe you'll try to figure this out. Try to watch both of these at the same time. You guys are smart, you'll figure it out. So I'm going to start that video in about 3, 2, 1, and now. So what I'm attempting to do here is narrate what I was saying at the time. So in 910, you guys didn't get to see example D worked out at the bottom of this page, where we're supposed to find the equation of a tangent line to a function at a particular x value. So in order to do that, to get the equation of any line, we always need to know a point that the line passes through, and we need to know the slope of that line. So in order to figure out the point that our line passes through, that's going to be our point of tangency. And since that's a point that's located on the original curve, we're going to go to this first line right here where we've labeled f of 1/2, and we're going to use the actual function itself and evaluate it at this given x value in order to figure out what that point of tangency is. And so as we're trying to find our point of tangency, which we're going to abbreviate as POT, we evaluate f of 1/2. Now since f in this problem was x squared, f of 1/2 is just going to be 1/2 squared, which is 1/4. And so now we know that our point of tangency, the one point we know that lies on this line, is 1/2, 1/4. The other thing we need to know about our line in order to write its equation is its slope. And since we're finding the slope of a tangent line, this is kind of the whole point of section 3.1. We can find the slope of a tangent line by evaluating our derivative, f prime of x, at a specific value of x. So we'll take that 1/2, the x value of our point of tangency, and plug it into the derivative. Our derivative was 2x, so this is 2 times 1/2, which just equals 1. So now we have the two pieces of information we need, the point of tangency, 1/2, 1/4, and the slope of the tangent, which is 1. And now that we know a point and the slope of our line, we're going to go to point-slope form. So we'll write that out as y minus k, which is 1/4, is equal to m, 1, times your x minus h, which is 1/2. So there's the equation in point-slope form. Now the directions weren't specific about what format we wanted the answer in, but your textbook is always going to put it in slope-intercept form, and they do pretty much the same thing for all of the AP tests. So we're going to take just a second here and transfer that into slope-intercept form. Don't really have to worry about distributing a 1, bringing that 1/4 to the other side. We're going to end up with y is equal to x minus 1/4. And that there is the equation of the line tangent to the graph of f of x at the point x equals 1/2.